Good afternoon, everybody. Welcome to class today. I'd like to go ahead and just get started off today by thanking you, as I'd like to do every time. Thank you for watching this live stream, whether you're watching it here with me live or you are watching the recording a little bit later on. I hope you're finding these things useful and important. You know, we're covering good information in these classes, in these live stream classes, that I think is designed to kind of help you out, to help you understand things just a little bit better. So I hope you're finding them as useful to you as I think they are, as I believe them to be. Now today we're going to be progressing onward and talking about Module 2, because Module 1 was last week. Now we're moving on to Module 2. And we're talking about variables, expressions, and statements. So we have some terms here that we're going to be defining, which is great. And this is kind of our first foray into doing some real programming. Like last week, you know, you were just kind of getting accustomed to the environment in the Module 1 labs. But now we're going to start progressing and getting more into programming and utilizing logic for programming. But before we get started talking about content today, just a couple of announcements. One is that, you know, I will be grading your lab assignments this week. I've already graded some of them. Need to finish up grading them. My policy is that I try to get everything graded within 7 days of the due date. So since everything was due this past Sunday, that'd be 7 days from that point. I'm usually pretty successful at that. Sometimes I get, you know, a little behind, but I try to stay within 7 days or as close to 7 days as possible in terms of getting information back to you and getting feedback back to you. And speaking of feedback, one of the important things going forward, which I don't know that there'll be a ton in the first module, we'll see. But one of the important things going forward will be to check that feedback, check those comments that you got back on these assignments after I've graded them. You know, you'll have the little speech bubble there beside the grade, and that's my comments back to you. And, you know, there is a lot of teaching that I do in there. You know, I'm trying to correct some errors and help you improve things if there's room for improvement. Like if there are things that you missed out on. So that's one of our goals here. And as always, if you have any questions about anything, feel free to contact me via email or Microsoft Teams, and we'll try to get things worked out. But today we're talking about variables, expressions, and statements. So these are, you know, again, we're talking big terms, right? Variables, expressions, and statements. Big terms, big vocabulary words. But what we're going to try to do is we're going to try to break these terms down as we try to do with our big programming words that we've been talking about over the past couple of weeks. One of our goals is to kind of demystify some of these terms that surround programming. Like last week when we were talking about algorithms and computations and what all that really means when we put it into perspective with what we do in programming. And so we're going to be doing a lot of the similar type of stuff this week in terms of talking about topics. So what is a variable? You might have heard this term before related to programming, talking about programming variables. At the very least, you've probably done math where there was a variable in an equation. And when you're doing your math, the variable that you have there is a little different than the variable that we have in programming. Now, at the core, the important thing about both the variable in math and the variable in programming is that it can be anything. That's kind of why we call it a variable. It can vary. We can change it from one part of our program to another part of our program. But I think in order for us to fully understand variables, what we need to first do is kind of take a step back and have this understanding of just what exactly is a variable. And so when we think about a variable, one of the ways that we can think about a variable is as a container. And I've got like a little Tupperware type of Gladware container here on the screen to kind of drive that point home. We're thinking about a variable as a container. And so essentially what we're doing with our container is we're creating this container. You can think of it like a box or a jar or whatever. And we put a label on it. So, you can kind of think of it like, maybe you've done some moving before. You take all your stuff, you put it in the moving box, and then you write on the side of the box what it is. You got this big box. I'm going to throw all my pots and pans into it, and then I'm going to write on the side of it pots and pans. Or I'm going to fill it full of stuff that was in my bedroom, and I'm going to write on the side of it bedroom. And it's kind of the same thing that we're looking at here in terms of what a variable is. Essentially, what we're doing here is we can take data and put it into this container via assignment. And then the name that we have on this container, whatever we choose to call this container, takes on this symbolic relationship with the data that we put inside of that container. So what we name the container has this symbolic relationship with what we put in the container. So it's just like we take one of those moving boxes, we write bedroom on it, we fill it full of sheets. Right? So we know later on that when we see bedroom, what that really means is that's our sheets. So we'll know where to unpack that and where to use that later on, or where to put that when we get to the new place. Because the name on the outside, whatever we name this variable, is referring to what is inside of this variable, the data that we put in this container. Now, you might have done some other programming before, maybe with Java, where something is what we would call strong typed. Where whenever you make a variable, you have to say, this is an integer variable, or this is a string variable, or this is a floating point variable. Just have it dependent on the data type in terms of what data can actually go in these containers. Python, on the other hand, is weak typed, which means once we create this variable, once we establish this container, put a name on it, and put some data into it, we can put any kind of data into a variable that we want to. And our Python interpreter is smart enough to understand the variable type that we put in there without having to declare a variable data type, or a data type for our variable. So the big thing as we're going into this here is that we're creating this container. We're putting something in the container, and the name on the outside of the container has this relationship with what's in the container. So when we refer to the name of that container later, what we're really talking about is the stuff that's inside. So variable creation is technically a two-part process. In the majority of programming languages, it's more evident than it is in Python. However, it is a two-part process because we have declaration and we have assignment. And these are our two parts of creating a variable. And in other, like I say, in other programming languages, we can do more to separate the idea of declaration and the idea of assignment. But in Python, even though these two concepts within variable creation are still present, we can't really separate them much in Python. There are some things that we can do to kind of take them apart, but overall, when we're declaring a variable, we're also going to be assigning it a value. So let's take a look at these in a little more depth. So we start with declaration, and declaration is just establishing that container. It's creating that container that we talked about earlier. So when I declare a variable, what I'm doing is I'm taking and making that container exist, and I'm putting a name on it. Via some kind of label. So what we're doing is we're creating this container and we're giving it a name. And with Python, as we've said, there's not really much of a process for declaration only variable creation, but in Java and JavaScript and many other programming languages, there are ways where you can just declare a variable and stop, and then assign it a value a little bit later on. So for those of you who will be going forward with me into like the Java classes later on, that's something that we'll explore there. But in Python, we're going to try to keep these processes of declaration and assignment married together. Now, how we name our variables becomes important. We have this variable name, and we can name our variable whatever we want within a set of rules, and we'll talk about these rules in just a minute. But they can be whatever you want. They can be as long as you like. You can name them really whatever you want. But there are some things that we want to consider as we're approaching naming a variable. One is that we want to name the variable something that makes sense. And this is something that we'll talk about a few times with different concepts. This idea of writing things in your program and naming things in your program in order to make sense. Because you kind of have to think about things this way, right? Like, in the real world, if you're programming, you're more than likely programming with a team. And so if other people are working on code with you, one of the things that's going to create a challenge is if you use ambiguous variable names and ambiguous function names and you don't include comments in your code, then the other people that work with you are going to have a hard time interpreting what you were trying to say so that they can build upon what you're working on. And that's going to be a struggle. And that's not something that you want. Now, conversely, we can frame it with the idea that, well, other people are going to have a hard time understanding what's going on here. But we can also frame it with the idea that you are going to have a hard time understanding what's going on. You're going to kind of have to think of it that way as well. Like if I'm working on a personal project, if I'm working on a project of my own, and, it might be pretty involved. It might be something that's taking me time. I'm working on it a little bit along. Friday afternoon, I decide to stop it for the weekend, or maybe I decide to go on vacation and not worry about it for a couple weeks. You ever worked on a project like that where you've just decided, you know what, I'm going to kind of put this away for a little while, return to it in a couple days or in a couple weeks, after vacation or after I've rested a little bit. Then I'm going to approach this problem with fresh eyes. And then the problem becomes that if you didn't use descriptive names that were unambiguous, that you could understand, then you might not even know what you meant 2 weeks ago or even 2 days ago. And so you end up having a problem where you're struggling to understand your own code, which becomes a serious issue, especially when you're trying to write good code and write code that's going to be effective and meaningful and easily able to be refactored as we work going forward. So one of the things that we want to think about is we want to think about creating variable names that are not ambiguous, that have meaning behind them. And the other thing that we want to think about when we're naming variables is that we name variables within our rules. We have a set of rules that we have to abide by as we're naming variables. So it's important for us to remember our variable naming rules as well. And so let's have a look at them. These are our variable naming rules. One is that variables cannot start with a number. Variables cannot start with a number. Because what happens is when my interpreter starts going through my code and starts reading the stuff that I've written, when it hits a number that interpreter thinks it's going to do math. That interpreter immediately thinks, okay, here's a number, I'm going to do math. But if you have some kind of weird variable name where it starts with a number and then maybe has a word or something else after it, that's not math that the interpreter understands. So it sees this number and it thinks, okay, I'm going to do math. Let's do math. And then it's just like, this isn't math. I don't know how to do this. What have you done? It's going to throw you an error every single time. So this is a big thing that we want to remember right up front. Now we can put a number inside of our variable or at the end of our variable, because then it's already reading the letter, then our interpreter is already reading the other letters that are a part of the string. So it knows that, whatever we have at the end is also going to be a part of that string. The big thing is not being able to start our variables with a number, because as soon as it sees that number at the start with nothing else before it, it's going to think time to do math. And then there's no math that can be done. Another thing is that variables cannot be a specific reserved keyword. So there are reserved keywords in Python and in all programming languages. And these when we say keywords here, we're talking about terms in the programming language that do something. I believe there's a list of them in your module reading material. But we're talking about things like class and object and string and all sorts of various terms that are a part of the programming language. So if it's already a part of the programming language, it already has a function. It already has something that it does. So we can't use it for anything else. It's reserved for the thing that it's already designed to do. And so there's not really a ton of these, believe it or not. We're fairly limited to what we are to the reserved keywords here. So it might just require you to be a little more creative in certain aspects of naming a variable. And the final thing that we have here is that variable names are specific. And what we're talking about here is something that we talked about a little bit last week. This idea that our computers are dumb, and when they see uppercase and lowercase letters, they think they're two completely different things. Remember that while we might see this word and this word, if somebody asked you as a smart human being to identify what both of these words are, well, you would say that they're both the word tree. They're both tree. That's the first word's tree and the second word's tree. They're both tree. But remember that our computer is dumb. It doesn't recognize letters in the same way we do. It recognizes letters based on their value on the ASCII chart. And so this letter T, the uppercase T, has a different value on the ASCII chart than our lowercase t. So these are two completely different letters. So this is just going to say that whenever you name a variable, that specific name that you used with the specific punctuation, the specific capitalization, if any, is going to be the standard for whenever you reference that variable later on in the program. Like if I declared a variable and assigned it a value and I said tree equals 7, and later on in my program I'm going to try to refer to that variable as capital T tree, my program interpreter is going to pitch a fit. It's going to say, I don't know this word. This is completely foreign to me. This was not declared anywhere. I don't know what this is. Because they're two entirely different terms. So that's another thing that we want to keep in mind. So these are our basic variable naming rules. But we also have some naming conventions in Python that we like to abide by. These are the PEP8 naming conventions. So you could see it written a couple different ways, PEP space 8, PEP dash 8, or just all as one word, PEP8. It's a document that provides guidelines and best practices on how you write Python code to make it standardized. And so when we're following PEP8 naming conventions, we have these specific guidelines for naming variables here. And so when we're using these conventions, which we should be using, we want to use lowercase letters as our variable name. And if there are multiple words in our variable name, we want to separate them with an underscore so that you can read them a little better. So for example, a convention in Java would be camel casing here. So if I were writing Java and creating a variable name, I might call it oak, capital T, tree, as all one word. So all these letters would be put together as one word. And the demarcation point here, the place where we can tell one word from another word, is this idea of camel casing, where we have this one letter that's capitalized in the middle of our word that denotes the transition from the word oak to the word tree. According to our PEP8 naming conventions in Python, we don't want to do this. We want to take our words, keep them all lowercase letters, and where we have the separation between the two words, we can just utilize an underscore to separate our words. So if we were writing this variable name in Python, it would look more like that, oak underscore tree. But that basically gets us through declaration. So let's talk a little bit about assignment. So an assignment statement gives a variable a value. So to think about this another way, a common way that we would write it if we were writing things on paper would be to have the name pointing to its value. So when we're talking about declaration and assignment, we could think about it in terms of the equal sign. The declaration is what happens on the left side of the equal sign. i.e. creating the name and putting the name there. And the assignment is what happens on the right side of the equal sign. Now, there are certain programming languages where you can do what they call Yoda assignment, Yoda variable assignment, where you can take and flip these around. You know, just like Yoda in Star Wars would like say his sentences backwards. You could take and flip these around and put the assignment on the left and the declaration on the right. But especially for our purposes where we're just starting to learn here, it's good to follow these conventions where we put the declaration on the left, the assignment on the right. That way we can read these variable declarations more like they're sentences, right? So I can have my variable name, x, and just read it as x equals 27. So let's kind of break this down and kind of talk about x equals 27 in terms of our container analogy. So essentially what we're doing here on the left-hand side, we have our declaration. We have this variable named x. Now, normally we wouldn't want to use a variable called x because it's not descriptive enough. But since there's no context here, it's a little hard to be descriptive. But essentially what we're doing here is we're establishing this container. We're slapping a label on it. And on that label, we're putting the name x. And so that's what we've done on the left-hand side of our equal sign here in terms of declaration. Now, on the right-hand side, we're assigning this value. So we're taking 27 and we're putting that into our container. So our container now has 27 in it. So whenever we refer to x later on in our program, it's going to be referring to the current value that's in our container. So unless we change this value in some way, which we'll talk about how we do that later on, we call that reassignment. Unless we change that value in some way, whenever we refer to x later on in our program, we call this, that x is going to be 27. It's going to go into, whenever our interpreter gets to that x, it's going to refer back to that variable, go inside of that variable, grab out whatever data is in there, bring it back and put it in place of that variable. Similarly, we have this hello world variable. So we're establishing our container. We're slapping this label on it of hello underscore world. The declaration that we have on the left-hand side of our equal sign. Then we're taking our string hello world and putting it inside of our container. So whenever we are referring to hello underscore world later on in our program, what we're actually referring to is the data that's inside of that container. So the string hello world. Now, one of the things that variables can start to help us do in programming is something that we call composition. So when we write a program, we want to break it down into smaller parts. This starts to get important now, and it will especially get more important later on when we get to things like functions. So when we take our program and we break it down into smaller parts, this gives us more flexibility. We're able to fix things when there are problems, and we're able to provide our user with more information. So when I say fixing things when there are problems, if we take things and we break it down in its smallest parts, and we're working with the smaller parts, and we test along the way to make sure that things are working, we know that if we add a small part and then test and something doesn't work, well, we only have to worry about the stuff that we added since the last test, because the last test would be a functioning test. So if we're able to break our program down into smaller pieces and we can start to do that with variables and test as we go incrementally, then we're able to fix problems when they arise, and we're not having to look through an entire program from top to bottom to try to figure out where things are wrong and where things need to be fixed. Also, in terms of providing information to our user, like there are steps that we can skip. And I'll do a demonstration for you in just a moment, showing you kind of what I mean about this. But there are steps that we can skip. But if we skip those steps, then the data that we could have gotten from those steps is not going to be available to us to pass on to our user. So if we include a step where we're passing something to a variable or kind of holding something in a little container variable just for a little while, then that's information that we could also give our user later on down the line, which might be important to some degree. So I'm going to jump out of this. I'm going to jump over into REPL now so that I can do a little demonstration. So here we are in our REPL. I'm going to go to create a new REPL. We're creating a new Python REPL. We'll name it variable test program, and then we'll create that REPL. So what I'd like to do is I'd like to create a little program here that's using just the things that we've done so far. So the operators from Module 1, where we did our math, and our new variables from Module 2, to create a program where we are going to be calculating the perimeter of a rectangle. So we'll need two sides, both of the adjacent sides, both pairs of the adjacent sides. And we'll need to be able to calculate those in a way where we're adding them all together. Wrong button. So as we're starting our program here, we're going to start our program with the thing that we're going to start every program with from here on out. We talked about it last week. That's the shebang. So that's hashtag bang or exclamation point /USR /bin /env Python 3. And remember, we said last week that this allows us to create a file that becomes kind of an executable, so we can run it without having to do some extra steps by double-clicking on it or running it from our command line. So this allows us to use this program in a better, more efficient, more flexible manner. And so what I want to do here is I want to create some variables. So I want to create a variable for each side to start off with. So we'll do side A. So that's side underscore A, because we're following our PEP8 naming conventions. Everything's all lowercase. Everything is, we have two separate words here that are separated by an underscore. Now you see we have our little red squiggle here, and that just kind of goes to show that we can't really unmarry declaration from assignment. Like if we were writing Java, we could write something like int side A, or if we were writing in JavaScript, we would write something like var side A, and then that would be enough. But in Python, it wants my assignment to go along with my declaration. So I'm going to go ahead and give it a value. So just a standard integer value, 10. And we'll go ahead and make a side B. And we'll set that equal to, we'll let this be the short side. We'll set that equal to 4. And so now we have these two variables. Now, we could write one equation here, call it perimeter, and set that equal to side A times 2 plus side B times 2. Something just that easy, right? But what are we missing here? What is some data that we might want to be able to share with our user that we're skipping over? Well, we have these two smaller equations here, where if we wanted to have a value 2 times side A and show them the length of both side A's, if we did it this way, we'd have to write another expression to cover that data, or we could just put it in some sort of intermediate variable to hold the information there in case we want to use it later. We might not use it later. We might never use it. But if we have another variable that has that data in it, we have the choice. So this is kind of one of the points of our composition rules. So if I write a variable, call it side A x2 for side A times 2, and we'll set it to this. Side A times 2. We'll make another variable for side B x2 we'll set it equal to this. So then all I have to do now is refer to side underscore A underscore x2 plus side underscore B underscore x2. And that's going to give me my perimeter. So we have all of this data here that we're kind of storing and keeping, kind of data hoarding, to a degree. Just because, maybe I want to use this data for something later. Maybe I want to be able to display this information to the user, or maybe I want to do some other kind of calculation with this, or something. Right? So breaking it down into these different parts allows us to temporarily store that information. So what we're doing now is all we have to do from here is just write our standard print statement. Print perimeter. And I can run this, and I get 28. So now the interesting thing from here is that all I have to do to be able to get a new value is change the value that we have inside of side A. So I might want to change that to 12, and I might want to change side B to 8. Run that again. Now it's 40. Now let's talk about typecasting for a minute, because we're going to need to do that here. Now, one of the places where things get a little iffy is when we're starting to use data of one type in an application where we actually need data of another type. For example, our perimeter here is an integer. But what if we want to put more information with this output here so that our user knows what they're looking at instead of just seeing the word 40? Well, we can use a process called concatenation. You learned about that in the first module. You learned about concatenation and repetition in the reading. And so I can take strings and I can add them together with plus signs to concatenate them. But this isn't a string, this is an integer. So if I wanted to say the perimeter of this rectangle is, we concatenate that, and we can concatenate that with units. So we end up with a sentence like this. The perimeter of this rectangle is whatever we get from our perimeter variable, units. Right? And so if we try to run this now, since perimeter is an integer and we're trying to concatenate it with these two strings, it's going to cause us a problem. So let's see what happens. We get this error message. Trace back. File, one of the important things that we need to do is we need to start learning how to read these error messages, because it gives us a ton of information in here. It tells us the file, it tells us what line the problem's on, and it gives us an idea of what the problem is. Right? Shows us the line of code we just wrote, and gives us can only concatenate string, not int. So what we have to do here is we have to do something called typecasting. That's where we take data of one type and we convert it to data of another type. Now, in Python, there are two primary times that we're going to have to do this. This is going to be one of them. The next one is going to be something that we talk about in the next module, where we're taking input from a user. Because when we get input from a user in, it's going to come in as a string, even if it's just numbers. So we'll have to be able to typecast from a string to an integer in that case. But right now, we're going to typecast from an integer to a string. And Python already has built-in methods that allow us to do this quickly and easily. I'm just going to type in around that variable name, str, and put that variable name inside of parentheses. And so that is going to give me the typecast value from an integer to a string of the integer value that we currently have in our perimeter container. So now if I run this now, I get the perimeter of this rectangle is 40 units. Now, we also have something here to point out. I did a couple things wrong on purpose. Remember that when we're in our strings and we're concatenating our strings, whatever is in the quotes becomes the string. So you see here we have 40 units, and there's no space between there. There should be. And that's because of what we've done here. In order to get a space in our output, we actually have to put a space in our string. So I need to come here before the U in units and add a space. So now that space has become a part of the string. So now if I run this now, we get the perimeter of the rectangle is 40 units. And it reads the way that we would want it to read. And again, remember that if we want to change this value, we just go in here and we change the values that are a part of side A and side B. And when we run that, we get our output. And so the thing to remember here is that whenever our interpreter is going through our linear data structure here, reading the different things, once it gets to a reference of a variable later on, it's going to go back and try to, and get the data that's inside of that container. So that's something that's critical to remember, that it's going back and getting data that's inside of that container. So if we try to get out of a container that doesn't exist yet, like if we were to move this, if we were to take these two lines and move them up here, that's going to cause a problem. And you can already see it's telling us there's a problem here. We've got these little red squiggles. Because our interpreter is going through, it's evaluating the statement, and it gets to here and it says, oh, let me go back and get side A. But if I go back, there's no side A. Side A is in the future. It hasn't got here yet. It doesn't know about side A and side B. So if you're going to be using a variable later on inside of another variable, like we did here, we need to have that variable first in the linear execution order so that our interpreter reads it, sees it, and understands it. So this gets us our conclusion. And if we want to make this a little fancier, like let's say we want to make a little headline for this, right? Well, maybe I want to make a variable called decoration. Or we'll call it deco. And I'm going to set it equal to colon times 8. And you learned about the repetition operator for strings in the first module. So if I'm using times on a string, it's going to give me that same thing 8 times. So instead of sitting there and typing 1, 2, 3, 4, 5, 6, 7, 8 colons, I can just refer to deco. And so now when I create a title, I can create a variable title, set that equal to deco plus a space perimeter finder space plus deco. So now instead of having to type out a bunch of colons, I have it in a variable, and I can use that variable over and over again. And so now we can just print that variable here, print title. And so now we'll get a title in addition to our output. Perimeter finder. The perimeter of this rectangle is 54 units. Now, one of the cool things is, if I say, this isn't really, I want more colons here to give me a little bit of decoration. Since I used my repetition, I can just change that to a bigger number, and it'll give me 12 colons instead of 8. So I'm changing one number and getting several things changed. I could also use something more, I could use like a little fancier sort of decoration. Like I could do something like that, where I have the bar character plus a dash and get a little thing like that. Maybe I want to do that plus another bar character so we get it wrapped up. And I'll change this to like 6. And then we get like a little fence pattern like that right there. So being able to think about these creative problem-solving ways to minimize the amount of stuff that we have to code, while at the same time giving us a lot of data that we can work with, is really going to be critical in terms of making good programs. So it's the kind of thing that we're looking at here. And so essentially what we have here, and we're still at a really beginner phase, right? Like ideally we don't want to have to hard code and change numbers inside of our program to make these changes, but we'll get to that later. Right? We'll put a pin in that, circle back around to it for module 3. But this, for where we are, is an example of a completed program. Like we have an algorithm, we've put into place these steps to do our computation being the problem that we want to figure out the perimeter of a rectangle. And so then we've established the algorithm that helps us find the perimeter of a rectangle, and we're displaying that to our users. So regardless of what we put into side A and side B, we get that outcome, which is pretty cool. So I'll leave this up on screen here for a second. If you're watching later, you can pause it. If you're here with me live, you might want to try to get caught up from this point. So I'll just kind of leave this on the screen here for just a moment while we get ready to talk about some other stuff. I'm getting close to wanting to wrap up, because we are kind of getting close to that 1 hour mark, which is really long for one of these live streams. But there is so much stuff that we can talk about, right? So since I don't want to go forever in the live streams, that also just goes to show like how important it is to go through and do the readings and watch the videos that are in the modules, because they're the primary methods of instruction in this online class, and then we are doing these live streams to support that. So, going through, doing the reading, watching the videos that are in the module before you complete the assignments, it's super important. But we can work through and we can make a program that does something super basic. And as we are progressing throughout the semester, I like to talk about this course as like a snowball rolling down a hill. The more that we go, the further we go along. If you imagine that like scene from old cartoons where like, you start a snowball rolling down a hill and it just gradually gets bigger and bigger and bigger and bigger until it's massive. That's more or less what we do in this class. We start with super basic, super easy, tiny stuff. And then as we learn more and as we're able to accommodate more knowledge and more pieces to what we know how to do, things progressively get a little more challenging. We're really kicking things up when we get to around Module 4. We're starting to really get into some serious stuff. And again, one of the important things is that, you learn all of the pieces that you need to know. So if you kind of think about this like a puzzle, right? I'm giving you a box with all the pieces. So we're learning each bit of code that we need to know to do the lab assignments and to progress in terms of what we understand with programming and logic. But where the challenge comes in is figuring out how all those pieces fit together to look like the picture on the box. The picture on the box being the lab assignments. So what we were just writing there, we call those expressions. So what is an expression? An expression is a combination of values, variables, and operators. So when we were doing the calculations, that's an expression. Any kind of value all by itself, any kind of variable all by itself, those are expressions. So really, every line of code that we wrote in that program that we just did is an expression. So another way that we can know what an expression is if when we type it in the prompt, our interpreter evaluates it. So we can look at that in relation to our console here. If I type in a variable declaration and assignment over here, I can say x equals 7. What it's going to do is it's going to evaluate that, and it's going to echo back to me 7. Or it's actually not going to echo back anything because I'm just creating a variable and I'm not having anything come back to me. But it's going to evaluate it and it's going to let me know. What would come back to me is if I told it, give me side A. It's going to echo back to me 21 because I have side A equaling 21 in my program. So that's kind of the shorthand way of how we can figure out what an expression is if we wrote it in our program and we go reference it in our console and it echoes something back out to us, then that is an expression. So what we're doing when we evaluate, that means that we're just finding the value of the expression. Conversely, we have a statement. And a statement is a unit of code that has an effect, like creating a variable or displaying a value. And so these are specific lines of code. Like you'll hear me refer to a print statement or an assignment statement, which is what we do when we give a value to a variable. When you type a statement, the interpreter executes it, which means that it does whatever the statement says. And in general, our statements don't have values. So that's like what you saw there in the example. When I tried to write x equals 7 in my console, it didn't echo anything back to me because it wasn't being evaluated. It was just a statement creating something. Now, if I had written that statement in my code and then typed x into my console, it would evaluate it and echo back to me the value of x. So that's what we're looking at here. Now, I've got this whole slide. I've got this whole slide here about order of operations, PEMDAS, and such. This same information is in your Blackboard reading, so I'm not going to read it to you. Basically, it's just the idea that programming follows the PEMDAS order of operations. So when you're doing math, you want to have that understanding. If you want to make sure something happens first, you put it in parentheses. Or string operations. I thought that was Module 1. I have a bad memory. It is Module 2. So we've already seen examples of these, so we don't have to go back and do them now. We can just talk about them for a minute. But in general, we can't perform mathematical operations on strings because they're not numbers, they're strings. So if we say things, so if we have some examples like you see here, where we're trying to take two words and use some kind of mathematical operator on them, it's not going to work. But we do have the plus sign, which is our concatenation operator with strings, and our multiplication sign, which is our repetition operator with strings. And so we've already seen those work because my memory's bad. And I can't remember what we did last week versus what I read earlier today to prepare for the live stream. But we saw that, when you concatenate with the plus sign, that takes the different strings, it puts them together. Whatever's in those strings is what it puts. So if you want a space between, you have to put a space in that string as well, even if it is a leading or a trailing space, i.e. a space at the start or the end of your line. And our multiplication symbol is going to repeat it. And so we saw examples of both of those in the little program that we just did. We also have this information here on comments. And this is where we'll end. Bigger, more complicated programs need comments. And it's for the same types of reasons why we were talking about earlier that we want to give our variables unique descriptive names. We want to be able to communicate to people what the purpose of part of a problem or part of a program does. Especially when we're getting a whole lot of code, a lot of dense code, where we've done a lot of work. We want to kind of write a little bit of a descriptor, so somebody who's coming in there after us, or even ourselves after we've had a long weekend or a nice vacation away, can look at the code and have an idea of what code does before we do it. Now, in general, if you want to write a single line code or a single line comment, we would use a hashtag. So for example, if I wanted to comment this line and say, oh, this calculate the perimeter by adding whatever, or I will start with a hashtag, and that hashtag is going to create my comment, and that's going to tell my interpreter to ignore this line. And I can just write calculate the perimeter. And so that line, you see it's kind of grayed out there. That's because it's a comment, and our interpreter ignores comments. And that's for writing a single line comment. If you want to write a multiple line comment, if you have a lot of things to describe, or you have a lot of information to put in something, like a lot of classes, a lot of other programming classes and other places will make you put like a little title thing at the top. You use a triple quote. So that'll be quote, quote, quote. And you can already see it turns everything red because just based on that, like it has commented out my entire program. So I need to go down a little ways and write another quote, quote, quote to end my block comment. And I can put some information in here like perimeter finder program, Mr. Ramsey, CIS 115, Introduction to Programming and Logic. The purpose of this program is to calculate the perimeter of a rectangle given two sides. And so with this block comment, I can put different comments on different lines. With our hashtag comment, that's a single line comment. So if I tried to hit enter and come down here below it, you can see it looks regular now because that's outside of the comment. That's a new thing. And as far as all this goes, with our comments, our interpreter is going to ignore them. So if we run this, nothing changes. We just have extra information inside of our program now that we can use to communicate with other people. So at this point, we have officially reached the hour mark, which is way over time than I want to spend on these. So this is where we're going to stop for the day. If you're here watching with me live, I'm going to hang out in the chat for just a couple minutes if you have any questions. If you're watching this later or you come up with a question later, feel free to email me or get in touch with me via Teams or whatever, and I will answer it to the best of my ability. But that's all that I have for you for this time. Thank you for watching, and we'll see you next time.